Hello students and friends. In this video, I'm going to discuss the topic of buffer solutions and particularly how we find out the pH of buffer solutions. Alright, and I have taken the question from the edexcel A-level paper whose reference is the 2023 IAL, and this is a unit 4 paper, but this type of question is equally valid for other A-level exams and IBDP exams. And so let's go forward and find out how this problem is to be done. By the way, I'm Manoj Verma from Mumbai, India. Okay, so this is a Bronsted glory base and its conjugate acid is shown below. So this is the skeletal formula for tris, and being a base, it accepts a proton and it forms its conjugate acid, and this is a buffer, and you have to explain how this mixture of this base tris and its conjugate acid acts as a buffer when a small amount of acid is added. Okay, so buffers, they maintain a nearly constant pH. So I will try to remind you about a formula which is generally used to find the pH of buffers. And in the case of a basic buffer, which is being shown over here, the formula takes this form: pH is equal to pKa plus log and the ratio of the concentration of the base and the concentration of the conjugate acid. So now if you look at the problem being asked, and they are saying that when some amount of acid is added uh, to this buffer, which consists of the mixture of these two, obviously according to Le Chatelier principle, when H plus ions are added, some of these the base molecules will react with the acid and change into the salt, into the acid salt, which will shift the equilibrium to the right, thereby slightly increasing the concentration of the acid and slightly decreasing the concentration of the base until a new equilibrium has been developed, right? But because the pH depends upon the ratio of the concentration of the base and the conjugate acid, and because you have to understand that in all the buffers uh, there is a large number of molecules of both the base and the conjugate acid, both are present in large amount. So being present in large amount, a slight increase in this concentration and a slight increase in this concentration does not significantly change this ratio. And because it does not significantly change this ratio, the pKa is anyway a constant, so the pH of this buffer remains almost constant, and that is how it is able to control the pH of the buffer. And this type of argument works for all the buffers. So hope you understood this. Let's go to the next part where it says that write the expression for Ka of the conjugate acid of the tris. So the conjugate acid of tris is this. If you go to the reaction given, then this is the conjugate acid, because this is the base. It accepts a proton and forms the conjugate acid. So now if you have to write the equation for the equilibrium of conjugate acid, you will have to write the reaction in reverse, because it is acting as an acid, so it is a proton donor, and it is helpful to understand the molecular formula of these compounds. So I have written down this formula again. I have shown all the hydrogens which are missing in this. So if you count, there are 4 carbons, 1, 2, 3 and 4. Hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 10 and 11. 1 nitrogen and 3 oxygens, and when a proton is added, 11 will become 12 and a positive charge will also be added. So you have to write the equation in which the acid equilibrium. So this acid gives you the base and the H plus. So the equation needs to be written in the reverse order, that is in this way. Okay, then the order which has been given. So the Ka will be, you will take the products concentrations in the numerator and the reactant concentration in the denominator, and this will be the expression for Ka. Now hydrochloric acid is added to tris. So when hydrochloric acid will be added to tris, it will change into the salt, correct? And now they have taken this salt. So how much salt have they taken? They've taken 100 gram of the salt and they have mixed it with 500 centimeter cube of 0.2 mole per dm cube of tris, and in this way a buffer has been made, and it's an alkaline buffer. It's an alkaline buffer because the amount of the base is actually greater and all of the base has not been completely neutralized by the acid, and they have given the Ka value of the conjugate acid which will be used in the working, and so we need to find the concentration, but here the mass is given, so we cannot use the mass directly. We have to change it into concentration. So we find the Mr by adding all the atomic masses of the acid salt, and it comes to this 157.5. And to find the number of moles, divide the mass by the molar mass and then divide by the volume, and you will get the concentration in moles per dm cube. So this is the concentration of the acid in mole per dm cube. Okay, now if you rearrange this expression, then H plus is equal to Ka into the acid and divided by the concentration of the base, and the concentration of the acid that you calculated over here is 1.2698, and the concentration of the base is 0.200 that has been given. So on solving this, you will get the concentration of H plus, which is this, and once you know the concentration of H plus, you can apply the formula for the pH, negative log of H plus concentration. The H plus concentration is this, and you can straight away get the formula, the value of pH. There is no need to write so many significant figures. You can write 3 significant figures as your final answer. So that's the pH of the buffer which has been made according to the instructions given here. Alternately, you can use the Henderson equation, and remember that for a basic buffer, because there is also an acidic buffer, for the basic buffer the formula is pH is equal to pKa plus log the concentration of the base upon the concentration of the acid. To find the pKa, you will have to use the relation negative log Ka. The value of Ka is given 8.413 into 10 raised to 9, and you can solve it by calculator and get the value of pKa, which comes to 8.075 plus log the concentration of the base was given as 0.200 mole per dm cube, and that of the acid you calculated as 1.2698. Put these values, solve it, and you get this part as minus 0.803, and you further solve it, you again get the same answer of the pH, that is 7.27, because these are the alternate methods. So please go through this problem once again slowly, try to understand each and every part, and you will be able to solve the problem based on the pH of buffers. This is one kind of problem. There are other kinds of problems which we can do later on in other videos. Thanks for watching, and if you liked it, please give it a like and subscribe to the channel. Thanks a lot.